Hello, good day everyone. KingzyViva by name, and I'll be taking some questions on WAEC further mathematics, quadratic equations, and then we have some few work here to do. As you can see, about four questions in all we've got to attend to, and I'll take what you can take for the day. Whatever is left will be done in the next video. So I'll move from the first question. And the first question here says if alpha and beta are the roots of the equation ax squared plus bx plus c equal to 0, show that alpha plus beta is equal to minus b over a and alpha beta is equal to c over a. That's a proof for the sum and the product of roots of the equation. So this is simple and we'll solve it right away. So um, we have the equation here. This is question 1 now I'm attending to. So this is question 1. We have the equation given to us, which is ax squared plus bx plus c equal to 0. And then we are told to find the sum of the roots of the equation. And the roots here, as we all know, is equal to is x, which is equal to plus minus b plus or minus the square root of b square minus 4ac all over 2a. We achieve this by solving this equation to find the roots with what we call computing the square method. So from here now, we now split out this equation now to give us x is equal to minus b plus root b square minus 4ac all over 2a. This is one of the roots now that we have here, and then and minus b minus root b square minus 4ac all over 2a. So we have two roots here. These are plus or minus. So we have plus, and here we have minus, the two roots of this equation. So having done this now, we can call one alpha and call one beta. But before then, we'll do something very quickly. We'll replace this b square minus 4ac by d. So we can say let b square minus 4ac be equal to d, where d is the discriminant. This is very important in equations like this, because this helps to deduce the nature of the roots of the given equation. So it's an important factor while solving these equations. I will expound this in the next video or later on, but just bear in mind that this is an important factor in this kind of equation given to us here. So we can now write x is equal to minus b plus root d over 2a, or minus b minus root d over 2a. Once this is done, the next thing now is to call one of the roots alpha and the other root beta. So I'll say alpha to be equal to um, minus b plus root d all over 2a, and beta will be equal to minus b minus root d all over 2a. So once you establish this, you now proceed to finding the sum. So to find the sum now, so the sum, so let's call down I. So I is the sum which is alpha plus beta. Is just basically to add up these two equations that are here to give us minus b plus root d over 2a plus minus b minus root d over 2a. So when we sum up this now, we have minus b plus root d minus b minus root d all over 2a, because they are both in the same base down. So just pick up and just, that means this divided by this is 1 times this. You see, have this here, and then this divided by this is also 1, then times this. You see, have that over here. So as simple as this is, we're almost done. This minus this will give me a 0, so they are both gone. And then minus b will give me minus 2b. So it will be equal to minus 2b all over 2a. And from here, we can now see that it's that 2 cancel out 2, and I'm left with alpha plus beta equal to minus b over a, and that settles the facts. Is proving that alpha plus beta is equal to minus b over a. To prove the next one now, which is alpha alpha beta, that's alpha times beta, that's the roots products. So that's the next thing to prove now, that is equal to c over a. That alpha beta is equal to c over a. So very quickly, we have the two roots here already. So from what we saw before now, we had the two roots over here, which were alpha and beta equal to this and equal to this. So this is beta, this is alpha. So I just multiply them to have um that's for number 2 now. Alpha beta is equal to minus b plus root d over 2a times minus b minus root d over 2a, and that's good to go. So this times this, and then this times this. So when I times this and this, okay, let's take it step by step. So alpha beta will be equal to minus b plus root d all into minus b minus root d all over 2a all into 2a. This will give us minus b times minus b is b square, and then minus b times minus root d is plus b root d, and then root d times minus b is minus b root d, and then root d times minus root d will be minus minus d. Yeah, that's minus d. So all over 2a times 2a is 4a square. How I got this minus d over here is basically root d times root d is like saying root d times root d, that will be equal to root d square, and then this is gone to equal to d. It's like having maybe root 9 times root 9. It's going to be equal to 9, because this will give me 3 and this will give me 3. So I'll still gonna have 9. So that was the law behind it. And then now from this point now, these two will cancel out, and I'm left with alpha beta being equal to b square minus d over 4a square. But then recall that but d is equal to b square minus 4ac from what we did before. At this point, we shouldn't forget this what we did here. So this is, I applied this over here now. So I'll put this value, this algebraic work for d here, and I move from there. So as alpha beta will be equal to b square and then minus bracket b square minus 4ac all over 4a square. This will give me b square minus b square plus 4ac over 4a square, and of course these two are gone, and I'm left now with alpha beta being equal to 4ac over 4a square. This means 4ac over 4e, and then 4 cancel out 4, a cancel out e, then alpha beta is equal to c over e, and that's about that. So again, it's proving that alpha beta is equal to c over e. Thanks for watching. We'll take the next one in the next video. We'll take this in the next video. Thank you.